So we have a final stoichiometry lab today.
Yes, final stoich lab, and a little bit of limiting reagent for you, a little bit of everything in this one. All right, so let's talk about the reaction real quick. We've got sodium phosphate. It will be aqueous. We'll dissolve it in water. And we have some calcium chloride that also starts out as a solid, but we'll dissolve it in water so it becomes aqueous. And then we're going to dump them together into the same beaker. And there's going to be a chemical reaction that happens. We wonder if you can figure out what type of reaction it is. Can you figure out who the products are going to be?
Wait a minute, you didn't write the products up here, Mr. Hubbard.
I know, because these guys are smart, Mr. Moore. They can figure this out,
Yes,
can't they?
yeah, yes, they can.
Figure out what the products are. We'll tell you one product is going to be aqueous, and one product is going to be a precipitate, which remembers that it's a solid. But I'm betting you can figure out what the products are and balance this equation. Okay, you're going to need a balanced chemical reaction to do the calculations here. Okay? Now, one little thing we haven't really seen yet is this reactant, the sodium phosphate, is actually a hydrate, which simply means there's water built into its crystal structure. For every one sodium phosphate particle, there are 12 water molecules. Now, that will not affect the chemical reaction at all. When this dissolves in water, those 12 waters just add with all the other water, and it doesn't make a bit of difference. But it makes a difference to you when you have to figure out how many moles you have. So you're going to have to find the molar mass of this so you can convert grams to moles. And so what you're going to do is find the molar mass of sodium phosphate and then add to it the mass of 12 water molecules. And that will be the mass of one of these particles. One mole of those particles, I should say.
Right. Okay, we can do that. So we have measured out 1 gram of each of those two reactants.
That's right. You'll see that in a second here. You'll start with 1 gram of each of these.
Okay.
So now limiting reagent will be important. You know, you're mixing amounts of two different things here. Somebody's going to run out first. You're going to have to decide who that is.
Yep.
Ultimately.
Okay.
Okay, so we've got things set up back here pretty well.
Oh, we didn't grab beakers.
Yeah.
Yeah, so Mr. Hell is going to grab some beakers. We have already weighed out. There's 1 gram of the sodium phosphate, that's that one. Then that calcium chloride is kind of a bead thing. So yeah, he's going to grab, we'll just put a little bit of water into each. We don't need to know how much water. The water just provides an environment for this reaction to happen in.
Okay, so here they are dry. I know Mr. Moore was mentioning that. Here's the calcium chloride. These nice little round pellets. I hope I don't drop any. So we'll dump those into some water. This is the sodium phosphate. We'll dump that in. And we got to get them to dissolve first. They have to be aqueous in order to react. Just about got it. Okay, you ready?
I think we're ready.
Okay, here we go. Boom.
All right.
Together. And you can tell we made a precipitate because it's cloudy and you can't see through it.
Yep.
There's a white precipitate in there. Now that's the product we're going to try to collect, or we will collect, on our filter paper. This is really old filter paper, Mr. Moore. It's like I've been in there and crunched.
Okay.
I'm afraid it's going to rip.
Yep. Well, maybe we'll stop this. This is a take 2 on the filter paper. 0.47 grams.
Okay.
The other one was old and cracked.
Yep. Some better days. Okay, so we're just gonna rig this up. This is a setup to do suction filtration. So we're gonna use some vacuum power to help speed up the filtering process. So we just fold the filter paper into a nice cone shape. We'll get it packed into our funnel. When we turn the water on, we get a suction effect.
Yeah.
The water rushes through the nozzle here, sucks air through this nozzle on the flask. So we create a vacuum down here, and that really speeds up the filtering process.
Yeah, that vacuum effect kind of pulls the water down through it.
Right.
And it traps the solid up there, and I got it. Sunlight right on that.
Yeah.
Yeah, but the precipitate's being collected in there.
So what'll happen is we'll filter this. We'll collect the solid on the filter paper, and it's Friday. We'll let it dry over the weekend, and then Monday morning we'll get a nice mass reading of our dried precipitate on the filter paper.
Yes, sir. That's what we're up to today.
Yep.
Okay, so we'll let that filter and dry the precipitate, and we'll be back. Mr. Hevel, 3 days later.
Mr. Moore, that's right. Monday morning.
Yep.
And our filter paper and precipitate is dried. And so we just need a final mass reading.
Oh, I've got this glare.
Glare.
Okay, yep. 1.20 grams.
1.20.
I think that's all we need. We can
It is.
find our percent yield now with that.
Okay.